call this meeting of the Water Planning Committee to order Tuesday, March 10th, 2015 at about 6:30 p.m. Now we take roll call.
Chairman Columbia.
Here.
Vice Chair Battern. Committee Member Menard.
Here.
Committee Member Hinman.
Here.
Committee Member Passion.
Here.
Committee Member Scheid.
Here.
Committee Member Sharp.
Here.
Committee Member Wilson. Here. Alternate Pankrazzi.
Here.
Committee Member Zedek and alternate Zedek are not able to attend a meeting tonight. Can I have a motion and a second to excuse Committee Member Zedek and alternate Zedek?
So moved.
I have a motion from Committee Member Wilson, sorry.
Second.
And a second from Passion, Committee Member Passion. Any discussions?
Yes, Mr. Chairman, has to get our committee approval to excuse someone or just to note their absence?
If you'll see,
Oh.
yeah, it comes later.
Okay, well, thank you. Okay, it was just, you said discussion. Okay.
That's okay.
How interesting.
Any other discussions? All those in favor say aye.
Aye.
All those opposed say nay. Motion passes. All of the members are present. So Committee Member Battern is absent from the meeting tonight. All other members are present. So, the first item on the agenda is to approve the draft minutes from the regular water planning meeting held on February 10th, 2015. Can I have a motion and a second to approve the draft minutes?
Motion to approve.
I have a motion from Committee Member Passion.
Second.
And a second from Committee Member Schneed. Item is open for committee discussions. Any comments?
Yes, Mr. Chairman, Peter Manerick, got two comments. I was surprised to see that you actually opened the meeting at 6:29. I don't mean, do we really want, I thought you opened it at 6:30, really. And I don't think it would have been wise for us to open the meeting before it was publicly announced. So I don't know if that's accurate, but I draw that. And the second thing is under committee discussion on page 6. I don't have a tape recording what I said, so perhaps the words are verbatim, but there certainly should have been, when I talked about the idea of subcommittees, my statement about not being sold on the idea, there should have been an adverb. And if I didn't say it, I would have wanted to have said it. I'm not necessarily committed to the idea, which is an important clarification. And the reason is for a different reason. This isn't because people can't talk enough, because I don't think, given our other responsibilities, that we can assess the information in the detail that we need to necessarily, throwing my adverb back in there, to understand the amount of information. I know personally, I don't think I have the time. But if I served in a subcommittee and I only had to look at one aspect in detail with two other members and report, I might. And as I mentioned, I also mentioned, and I don't know when this will come up, that I wanted to bring the meeting, that idea up under new business at this meeting, and I said I was going to bring it up ahead of time and try to amend the agenda. So those are my comments about the minutes.
So we'll talk about that. It's on the agenda if you look at 6.4 tonight, so we can talk more about it in detail.
Yeah. Well, we're talking about the minutes now.
Okay.
Yeah, I saw that it was on the agenda.
Okay. Do you want me to go back and review the minutes?
I don't know how we handle
Or the
the
video.
minutes.
It sounded like you were talking about the video earlier. So
I'm
would
talking
you
about
like
the
me-
minutes. No, I'm talking about the minutes.
Okay. Would you like me to go? Would you like me to go over the minutes, or?
No.
Respectfully, Chairman, I believe someone could make a motion on the minutes as amended by a committee member Menard, if somebody would like to so move.
I just want to make sure they're right. And if they're right, that's fine. That we opened the meeting at 6:29 and that he didn't say those things, that's fine. And if yeah.
Okay.
That's all.
Okay, that's all?
Yeah, I just want to make sure they're right.
All right.
Because I didn't mean to say those things, but if I did, I've said misspoken before, and I didn't know if we really started the meeting at 6:29 instead of 6:30.
I saw 6:30, but that's okay.
Well, then we should not have it at 6:29, sir.
All right. Where were we? On,
The motion's still on the table. That was the
Okay.
discussion.
yeah. So who's positioning that?
Ask committee member Monarch to please restate the motion.
Can you please restate the motion?
Well, if you believe, Mr. Chairman, that you called the meeting to order at 6:30, I would like to amend the minutes that you indeed called the meeting to order at 6:30.
I feel I've called the meeting at 6:30. I looked at the clock, so,
I thought you said that.
okay. So should we do a motion for that? Okay, so can I? Well, should we get through this one first?
No, Chairman, respectfully, I think if committee member Monarch would like to move that the minutes be amended to change the time to 6:30 and add necessarily as the adverb, that the motion, that the minutes be approved. That would be his motion.
We have two motions. That's the way I'm seeing it. We've got the time, and then he's got the verb that he would like changed. That's how I'm seeing it. Is that correct?
That's it. Well, if it's accurate. I mean, if there's, but I'm going to approve the minute. The real thing I want to get corrected is 6:30.
Okay.
And now that I've made this comment,
Okay.
we
So-
can just move it and move on. I don't want to.
all right. So we need so we should have a motion, correct? Okay. Can I have a?
Then I move the minutes be amended that read that you started the meeting at 6:30.
Second.
There we go.
That's all.
So, okay. So I had a motion from committee member
Minerick.
Menerick and a second from committee member Inman. So let's try that again. Is there any other open committee discussions? Any comments? All right. All those in favor say aye.
Aye.
All those opposed say nay. So the motion carries. All right, now it's time for citizens who would like to address the Water Planning Committee. Are there any speakers? Does anyone in the audience wish to speak? Someone smiling back there. Quiet crowd. Okay. We have no old business on the agenda for this meeting. Moving on to new business, I'll turn this over to Facilitator Teresa Mackin.
Thank you. Thank you, Chairman. So we're going to go ahead and start in the presentation. We have a long presentation this evening, which is just one part of two parts of a presentation on the Integrated Water Master Plan. First, I'd like to just reorient you to the timeline. We're in that second pillar that you can see, and about the second one down says the Integrated Water Master Plan. And we're moving forward, still trying to give you the information that you need, and then ultimately in May, we'll have the rate study information for you. Next slide, please.
You ready?
Yes, sir. All right, so tonight is, as I mentioned, the first of two parts, and this one you're going to receive information on the Integrated Water Master Plan. Next month, you'll see how that relates to project costs and staff recommendations. So for administration night, we want to make sure you have time for some more discussion. So what we've done tonight is we're trying it another way, and we are going to integrate Guy Carpenter with Carollo and his team have picked points where they can have a break, and so we'll stop a few slides in or however far in, and then we'll say, is there any discussion? So if you wouldn't mind, we're kind of doing a hybrid of the ones we've done. So if you wouldn't mind writing down your questions, and then when they get to that break, I think there's 3 of them, so there's several. And then we'll open it up to questions and make sure, and we want to try and keep them on point so we're, with the goal of trying to move towards the information for the rate study. And then at the end, we'll still have dedicated time for committee discussion. We hope that'll work out best. And here we go. This is Guy Carpenter with Carollo Engineers.
Hello, everybody. I'm Guy Carpenter. I'm a vice president for Carollo Engineers. We were hired to do your Integrated Water Resources Master Plan. With me tonight are Richard Humphreys to my right, and then to my right, 2 doors down, is Rob Buss. A silent partner we have in the audience is Eric McCleskey. He's in the purple shirt over there with the tie. He's another member of our team. So I wanted to make sure you knew who they were. We're here tonight to talk about the 5-year water and wastewater capital improvement program for the city here. So the purpose of this presentation is to describe how the 5-year water and wastewater CIP projects were developed. And CIP stands for Capital Improvement Program. We'll be using that acronym a lot tonight, CIP. There's some other important terms that we will be using tonight. The first one is level of service. Basically, these are measurements that define what a customer expects to receive. And when we're talking about water utility services, we're talking about, especially with the water system, in terms of pressure, reliability, water quality, and if you have enough water and pressure to put out a fire. Those are the types of things that we look at for level of service. Performance criteria are the specific metrics against which a water system is compared to determine if the water system is performing in an acceptable way. And Richard will go into a great deal of detail on what we're using for performance criteria. A peaking factor is something that you'll hear quite a bit when we talk about master planning, and it's basically a multiplier that we multiply against the average day demand to make sure that you have system capacity and water supply necessary for a peak condition, usually in about the middle to the end of June is when most cities in Arizona experience that peak condition. So we'll be applying a multiplier so that you've got sufficient capacity and water supply for that. Firm capacity is basically a term that's used to indicate the amount of water that a pump station can pump with its largest pump out. So what we want to do is make sure that, because these are mechanical equipment that do fail, when one fails, you still have a firm capacity to make the deliveries that you need to make. And again, CIP stands for Capital Improvement Program, which is a listing of the projects that will be constructed, that need to be constructed. And it's going to have a detailed description of each project and then a cost information as well as the timing that that needs to be done in. So you'll see that term quite a bit. What we're going to be talking tonight are up on the board here, infrastructure master planning, what goes into that, give you a little education about what goes into putting together a master plan. We'll get into a great deal of detail on levels of service and performance criteria. Rob Buss is going to talk about the condition assessment work that we've done. And then we're going to talk about some of the water and wastewater projects and water project prioritization at another time. So basically tonight we'll be ending at condition assessment. Okay, so that's where we'll end tonight. As far as infrastructure master planning, this master plan aligns the water resources and infrastructure with Goodyear's general plan. It is an integrated master plan, and the reason we call it an integrated plan is because we're looking at the interrelationships between your water resources, the water system, the wastewater system, and the reclaimed water system. And together, those form infrastructure that help the city create a highly desirable and sustainable place for all to live, work, visit, and play. That is right out of your general plan that was approved in November, and this infrastructure plan goes to support that vision. Another diagram that's in the general plan is this one, which is basically showing how the general plan forms the foundation for what the city is trying to accomplish to achieve its vision. And within that, we then look at master planning for a wide variety of things. Our particular task is on the water utilities. And out of this master plan, you may end up having some codes and ordinances that you want to make changes to with regard to water resources, water conservation, the way that you use recycled water. As well, we will be developing the capital improvement program for the water and wastewater systems. And that affects what is ultimately built as far as the infrastructure that goes into the city to meet your vision. The general plan also includes the land use plans. And what we use the land use plans is to tell us the kind of intensity of development that's going to happen. It helps us size the facilities that are necessary. When you look at, when you get the final master plan at the end of our project, you'll notice that the pipe sizes are different in different parts of the city. And that's because the intensity of population is different throughout the city. And it's responsive to this plan. So we're putting in infrastructure necessary to meet the demands associated with the particular location in the city. So the integrated water, wastewater, and reclaimed water master plan project has a bunch of major tasks. And I'm going to go through those. The first two are the 5-year CIP, again, Capital Improvement Program, and a Southern Solutions Plan, as well as a condition assessment project, the first phase of that. And basically, these two tasks together form the basis of a 5-year plan that is needed for what your existing population is. So we're not looking at anything growth related right now. We're looking at just what it's going to take in the next 5 years according to the performance criteria that you need to have for the level of service that your city expects. And then later on, we're going to be doing these other tasks where we go through each one of the water resources, the water system, the wastewater system, and the reclaimed water system. Now, normally, when a city hires us to do a project like this, we do the whole thing. And we put together a capital improvement program that's for the near term as well as for the long term. But because you have a rate study going on right now, the city asked us to go ahead and do the first phase of this up front, get it done quickly for the near term for your existing population, and then we will go back and do the rest of it later. So that's how we're proceeding with this project. So what's the basis for evaluating your infrastructure needs? Well, again, we're looking at the level of service. This is, again, what the customers expect in terms of flow, pressure, water quality. We look at state statutes as well as engineering practice that dictate what the performance standards are for a water or a wastewater system. Those are all performance criteria that go into dictating the amount of capacity that you need for new infrastructure. That's on the right there, the new infrastructure development. But the other part of it is we can't just assume that the new infrastructure is enough to meet the needs. You also have to assess your existing infrastructure to make sure that it's in proper condition to deliver the type of service that you want. So existing pump stations, lift stations, the pipe conditions, that type of thing is the other thing that we look at. And Rob Buss will get into a lot of detail on that. So the purpose of the capital improvement plan is to, first of all, identify what capital needs you need for new systems, new facilities. Look at what the condition is, again, of existing facilities. This here is a manhole that goes into the sewer. And that, I should have said that this is a pump station, a well and pump station for delivering water supply into the system. And then finally what we do is we look at what the funding requirements are for all of the projects necessary to meet those needs. And with that, we'll take a break just for questions so you understand, make sure you understand the basis for how we go forward with the master plan.
Any questions at this point?
Okay?
Okay.
Richard?
All right, next we'll talk about the levels of service and what that means and how we use this in our planning work. What levels of service do your customers expect? And this table here that we're going to put up has levels of service in several categories: supply interruptions, minimum pressure assurance, and fire flow, as well as water quality, just to show you examples of levels of service and how those levels of service could vary. And we're going to rank them from high to low. So number one in this case is, we're going to call it level 1. And this water system would have no supply interruptions under any conditions. It does have a guarantee of minimum pressures that would be provided at all times, both for normal operating conditions and for a fire flow or other emergency conditions. And your fire flows, as defined by your fire marshal, would be available at any time, day or night, if you had a fire event. Let's go down to the next level, level number 2. This could be the public would allow or be tolerant of supply interruptions. For example, if you had a natural emergency like a haboob went and took out a number of power lines and disrupted the electrical supply. Another example in, let's say, California, for example, would be where they had an earthquake that would interrupt your supply of water. The next category, minimum pressure assurance, that would be provided most of the time, except in some of these major natural emergency kinds of events. And fire flow also would be available, except there could be some interruptions during these extreme events. Now, that you might argue that could also be a little bit problematic, because if you've got earthquakes, for example, that could be when you also have some fairly significant fires and would want protection for that. If you go down to the next level, level number 3 on supply interruptions would be an interruption to your water supply when you had an equipment failure, a pump went down or a pump station failed or some other kind of event, which is a failure of the component of your water system. Minimum pressures are usually provided, but under some circumstances you may not receive your minimum pressure. And the fire flow, again, is usually provided, except in some of these kinds of emergencies when the fire flow could be disrupted. The next level down would be supply interruptions during peak demand conditions. Without any infrastructure out, it just means that your infrastructure is not quite sized large enough to handle your peak demands. Your minimum pressures are not always delivered. Again, if you have problems or demands on a hot day, your pressures are going to droop and be less than what you'd normally expect. And the fire flows could be limited. You may, in some situations, not be able to get any water at all during a fire event, or you may be able to get some water, but not the water that is really supposed to be delivered by the standards. And then the fifth level in this table would be supply interruptions daily. Perhaps you would only get water for a part of the day. Minimum pressure assurance, but there would be none. And also fire flow. There's really no assurance that you could get a fire flow in that kind of condition. And typically you would see levels 4 and 5 more in a third world country than what you would see here in the United States. For water quality, here in the United States, we have water quality standards that you must comply with, and you really don't get a choice as to whether or not you meet those standards. It's expected that you comply with all water quality standards. So the level of service includes several things in delivering that level of service. It determines the investment a community is willing to make to manage their risk. Because you can have additional redundancy in a water system, which costs money, obviously, to provide, but it also lowers your risk. So it's a balancing act that cities and water delivery organizations have to manage their costs and their risk. And the third one is customer expectations. Each of you, as well as your neighbors and businesses and industries in your community, have some expectation about what kind of water service they're going to receive, what kind of pressures and reliability, and what's going to happen in an emergency. And in addition, there may be people who may move into your community that also have expectations, and they may compare the city of Goodyear with other communities they've lived with or others around here to see what you provide in comparison with what other cities might provide. Investments in a water system beyond the absolute minimum are designed to provide safety and reliability. These are some causes of water supply interruptions. And these are not necessarily all the causes, but you can have well failures, you can have well water contamination, equipment failures, hazardous material releases, an extended power failure, waterborne diseases. You have issues with drought or pipe failures or vandalism. There are any number of problems or disasters that could happen that could interrupt your water supply. So then we come back to the question, well, what reliability do you need and what are you willing to pay for? When it comes to predicting future failure events, sometimes the question we're asked is, well, can you tell me what would happen if I don't do this or if I don't do that to enhance the reliability of your system? You know, what am I protecting you against? And I need to point out that it's impossible to predict future specific failures. Just like it's impossible for me to predict when you or I might have a flat tire on our car or when we might have some other component go out. We don't know the future. However, there are some things we do know. The ultimate failure of most infrastructure is guaranteed. The infrastructure you put in may last a very long time. Some may last more than a person's lifetime. But ultimately, infrastructure fails, electronics fail, mechanical equipment wears out, and you have things such as corrosion that contribute to failures in a system. And so it's not about putting in a water system and infrastructure to protect against specific events. It's a matter of putting in infrastructure to protect against a variety of different events that could occur, with the hope that if you do it right, you can avoid interruptions to water supply that your customers might expect. So when we come to developing standards for safety and reliability, it's a little bit analogous to a car. Any car that you buy on the market today is going to have a spare tire. It's going to have a backup parking brake that you could use in an emergency. Cars all have a dual latch hood, so if the first latch fails, your hood doesn't come flying up in front of you so you can't see. Cars have seat belts plus airbags, and there's spare electrical fuses in the jockey box or in your fuse container. So the performance criteria that we use for water systems is designed to do something similar, to provide a standard redundancy for water systems, to provide the level of service that is expected for a water system, and providing water supply is a weighty responsibility. You've got thousands of people who are depending upon that water every day for their service, and most communities also have people that have health issues or kidney failures or other things that also depend on a reliable water supply. Now let's look at a couple case studies that have happened here in the Valley in recent years to evaluate water supply and what happens when a failure occurs. The Val Vista Water Treatment Plant is located in Mesa, and it is co-owned by the cities of Phoenix and Mesa. A few years ago, you may remember we had the Rodeo Chittisky fire that burned a large area on the Salt River project drainage area. And inevitably, when you have a large failure like that, you have storms and then runoff, and then the water from that area is contaminated with the ash and carbon and so on from that fire event. Not too long prior to when this occurred, the city of Phoenix undertook a project to optimize the operation of their system. And so they did some studies, and they had some consultants help them figure out what they could do to reduce their operating costs to be able to operate their water system at a lower cost. Then when this event happened, they had an emergency, and they had to issue a boil water notice telling people they had to boil water before they could drink it. And that created problems that was certainly less than the expectations that many of their customers had. And when they had this problem, part of the challenge that the city of Phoenix had was that they had wells previously that they had used and could use to provide some level of redundancy. But at this point in time, they had taken those wells offline, and so they could not turn the wells on to provide a replacement water supply when they had this problem with the Val Vista Water Treatment Plant. By contrast, the city of Mesa kept their wells. And so when this event happened, what the city of Mesa did was they closed the valves to isolate their water system from the pipelines coming from the Val Vista Water Treatment Plant. They turned on their wells, and so they didn't issue any kind of a boil water notice or have any kind of emergency that affected their customers. The absolute minimum cost exposes cities to risks that are unacceptable to customers. And we were asked to do a study of what happened and what was the cause of the problems as to why they were not able to deliver water as expected. And what had happened was this optimization study identified that they could remove some of the staff at the plant, so they were running on more of a skeleton crew. The study also found out that they had reduced the training to their operators, so they had operators that weren't fully trained and prepared to handle this kind of an emergency event. And so that was the cause of their inability to deliver water that met the standard during this particular event. So now let's look at another event, and this particular case study was the city of Goodyear last summer. This particular slide shows a map of the Goodyear service area, and there are 5 different red areas that kind of draw a polygon around the different water supply infrastructure that you have. If you're going from the lower left-hand corner, you've got Site 12 with 1 well. Above that, you've got the Adaman wells, number 1 and 2, that goes into Site 21. Then over on the right side, you've got wells 18A and B and well 1 and well 6 that deliver water into the distribution system. Well 3 is kind of by itself. And then right in the center, you've got a group of 5 wells that deliver to your Bullard Water Campus. Of these wells, 2 of them go into the reverse osmosis treatment system that is at that site. The other 3 deliver water to a storage reservoir at that site. And so what happens is the 2 wells have treated water that then goes into that storage reservoir that is blended with water from the 3 other wells that don't quite meet the standard, but when it is blended with the treated water, then you do meet the standard. So on the day of this event, this is what happened. The VFD failed on well number 22. The VFD is an electrical device that controls the speed of the motor at that well. There was a component that failed, and so that well no longer could be used. Well number 20 is one of the wells that delivers water into the storage reservoir to blend with the water from well 22. At that point in time, the central planning area had usable storage, excluding fire flow storage, of 5.98, almost 6 million gallons of storage. The water demand at the time of that event was 11.7 million gallons per day. The total production of all the wells in your system was 12.9 million gallons per day. So you only had 1.2 million gallons per day of excess production with every well on. Wells 20 and 22 both produce more than 2 MGD, so this created a problem. When well 22 fails, that drops your production with the remaining wells on back to 10.9 million gallons per day. Your water demand is 11.7 million gallons per day, so you had a supply deficit of 0.8 million gallons per day. So with only that well going down, the consequences are that within a 24-hour period, you're no longer able to meet the standard on your water quality. The TDS and also the nitrate levels rise up above the limit. You have some water storage that can help you out for a time. That storage would be gone in 7.5 days. So if you had an outage for a longer period of time in getting the repair done, you would have to implement drought restrictions in order to maintain a water supply to your most critical needs without being able to supply some of your other needs. And then if you had a fire during that point in time, then that would have compounded the issues. So now if to meet the water quality standard, you also shut down well number 22, which is what was done, that means you had production of 8.5 million gallons per day, water demand of 11.7 million gallons per day, which means that your water storage would have been used up in the central planning area in just under 2 days' time. you would have had to implement drought restrictions, and again, a fire would have compounded the issues. Fortunately, in this case, they were able to get the parts that went bad and implement it to where the citizens did not experience any drop in water service, but you were very close to having that because of one electrical component failure. So this is another case where redundancy becomes very important and able to provide a reliable water supply. When cities do experience a failure to deliver water of some sort, these are the consequences that they have experienced. First of all, there's a loss of public trust. When they do go to do a repair in an emergency repairs inevitably will cost more than repairs under normal conditions. If the issue goes unresolved, it does pose a threat to public health and safety. When you have a damage to public trust, then it also becomes more difficult to obtain funding with that lower level of trust. And then if it occurs over a longer period of time, that can constrain growth and development if people who would move to the city would perceive the level of water supply service to be less than what they might expect. So now we're at the next point where we can stop and ask questions. Do any of you have questions over the things we've talked about in the last section?
I've got a question. On page 11, you were talking about reliability studies.
Right.
You kind of briefed over it. I'm just kind of curious what type of halt testing has been done with some of the capital equipment. You familiar with halt testing?
Halt testing, that's not a term I'm familiar with.
Highly accelerated life testing for products. So typically like that VFD unit
Right.
had to have went through some type of testing. So it sounds like you're not familiar with that. I was just kind of curious, what type of testing will the capital equipment go through prior to being installed? So,
Yeah, I'm not sure of the specifics of that for the city of Goodyear, but okay.
then how about this? What other types of reliability studies are you aware of that they do for these products? The pumps, the pipes, electronic components, those types of things.
One of the kinds of testing that has been done, I mean, we did some at a level as a part of this that Rob is going to talk to, where we go through and evaluate your equipment, your infrastructure, and evaluate the condition of that. Do some level of inspections, for example, at the manholes, and look at corrosion and other kinds of issues that may occur in your water or wastewater collection system.
Maybe I'm thinking ahead of time, like this VFD. What's the life expectancy of that product? And it failed, right? We all
Right.
know it fails. How old was that product? What's the life expectancy of that product?
I don't know how old that particular component was.
Uh-oh.
And I think I'm going to try and answer part of your question on the other one too. Every pump, every motor comes with either a pump curve or some kind of efficiency rating on the pump and the motor. And we'll match that against, we'll do pump testing. When we buy a pump, we install a pump. We'll go through a pump test to make sure that the flows that are on those pump curves match what we're actually seeing in production. So we do that kind of stuff when we buy new equipment. Okay? Does that answer the first part of the question?
That's good
Okay.
there.
On the second part of the question, this particular VFD was a 1998 vintage piece of equipment, and it had been in working order, and it had been working all that time, and all it takes is one small little diode that went out that shut the whole thing down. It's one of those electrical components that it was aged.
What was the life expectancy of that product? I mean, now you just said 1998. That does seem quite...
going to O&M manuals, electronics can be 30 minutes, 30 miles over.
Usually you'll say how long.
Yeah, 5 years at a minimum, I would think, but
We're looking at, 17 years?
Yeah. It's aged equipment.
So is there some type of program that says, okay, this guy is 17 years old, I think it's time to take a look at it? And
We're doing that through our asset management program,
okay.
trying to evaluate all the existing equipment now and
this
trying to
one got
identify
missed.
those. This one got,
Gotcha.
it failed before we can get to it. So,
17 years.
yep.
Mark, do you have ongoing preventive maintenance with all the equipment?
We do.
Other questions?
Yes, I have a question. Just to get the context of the presentation, are you consulting to advise the city on a cost-benefit analysis for capital improvement? Is that the basis for what the contract is for? Do I understand?
No, our contract is to provide an engineering evaluation of your infrastructure requirements, both for existing customers. That's what we've done up to this point. When we go into some of the other steps of the project, which Guy referred to very briefly, we'll also look at growth and future customers. But our task for this particular item that we're reporting on was to measure your water and wastewater system against standard engineering practices and criteria to see how the system measures up.
The requirements is the key word there.
Right.
Well, how is that not a cost-benefit analysis? I'm just trying to get the context of what you're doing to understand the presentation.
Well, we're providing infrastructure recommendations. We provide planning level cost in comparison with the performance criteria that we're going to talk about in the next part. What we're not doing is telling you anything about what part of that you fund or impact on your rates. All we're telling you is to meet this standard, this is the infrastructure that would be required, and this is what the cost would be.
Thank you. Understand the answer. Then a follow-up then. So what you're talking about is with the assumption that there's an adequate water supply absent a natural disaster. Do I understand that to be correct?
Well, we haven't, at this point, we haven't stated specifically, all we've done up to this point is talk about kind of the foundation upon which we get to the performance criteria, which we're going to talk about next. So we're not really
It's a long-range question. I don't mean to belabor the point, but it's capital improvement. So we're just concentrating on the requirements as if there was a sustainable and affordable source of water. That's one thing.
right.
And if that's the assumption, then I understand the presentation in one context. But is there any type of understanding when you're doing this that there may be a capital improvement need if there's sustainability problems?
Are you referring to the water resource availability?
That's exactly, sir,
Okay.
what I'm talking about.
Right. The water resources is part of the plan. It's part of the integrated master plan.
That's right.
But it's not one that we have completed yet. But we are going to evaluate your water resources and availability, possible water source against your growth plans. That's yet to come in our study.
Thank you. That's what okay. So that under the capital improvement is the expectation, having those requirements to meet that, given possible problems with sustainability.
Right. When we do the integrated water resources portion of that, we are going to look at your ability to look at your water resources portfolio and then compare that with the ability to deliver that long term and to support additional customers.
Thank you. I understand the answer.
Okay.
Any other questions from the committee? Okay. Do you continue, or did you give it to Rob?
I continue on this
Okay.
one. I think Rob is next.
Yeah, we're going to get into the details of the performance criteria now to help you understand kind of the baseline condition that any city water system should carry to meet the basic service levels.
So when we talk about performance criteria as it applies to a water system, there's basically 7 areas where we have criteria that is defined. The core of that obviously is your water supply, and then around that is your pumping capability, water transmission, water storage, and pressure. You also have standards for fire flow and for water quality. And so we're going to go through and talk about these with the exception of water quality, since you don't really get to make any choices about that. And there's a lot of constituents that would be a complex presentation by itself. First of all, let's talk about the standards that are the state minimum requirements as shown in the the Arizona Administrative Code, which also references another document called Engineering Bulletin number 10, which is a water supply system design document. Now, these standards, as it says, are minimum standards, and they also were designed to apply to everything from a small little residential neighborhood that may only have half a dozen houses and is not connected to any other municipal supply, all the way up to the city of Phoenix. And so with these standards, we need to work with them and apply them to the specific needs that every community has. The first standard is the minimum pressure for emergencies, such as a fire, is 20 psi in all parts of the water system. That one is very standard. Everyone expects to be able to deliver that. The next one is that the minimum non-emergency operating pressure is 40 psi. And most cities strive or plan to be able to deliver 40 psi. There are some cities that have a goal of providing a higher pressure. The next one, pump station firm capacity is equal to the pumping capacity with the largest pump out of service. Guy touched on that briefly. So any pump station that's designed to deliver water service will have one spare pump in it. The next one, the minimum water storage is equal to the average daily demand of the maximum demand a month. Now, this storage criteria is directly out of the Arizona Administrative Code. There are some situations where cities may have different criteria based on their unique situation and their requirements. And then the next one is the fire flow according to current ISO standards, where when we do planning, we typically will have a residential fire flow amount that we need to deliver and a commercial fire flow amount. When you actually go to construct buildings and your water system, there are specific fire flow requirements that your fire marshal will have for specific buildings that is dependent upon the building type and method of construction. International Standards Organization. And then, as I mentioned, all water quality standards. So now I'm going to go through the specific performance criteria that the city of Goodyear uses. So the pressure performance criteria is to maintain pressures between 40 psi and 80 psi. The reason 80 psi is a limit is that for pressures in water distribution systems that are higher than 80 psi, they're required to provide a service line pressure reducing valve in order to protect the water heaters in homes. The next criteria, the water transmission performance criteria, is also essentially the same for all cities, where for any pipe less than 36 inches in diameter, they design to keep the water velocity less than 5 feet per second. For pipes greater than 36 inches in diameter, they allow velocities up to 6 feet per second. For peak hour demands, the peak hour is the highest demand hour of the day. The standard is to keep the velocities less than 7 feet per second. And then the fire flow demand, the velocity is to be less than 10 feet per second.
So all of those just affect the sizing of the pipe to keep within that tolerance, basically, under those very conditions.
And one of the reasons that you want to keep the velocities lower is that your energy loss increases with the square of the velocity. So when the velocities get too high, you also start to get very high pumping energy costs. And it also becomes very difficult to deliver fire flows. For the fire flow performance criteria, the minimum pressure of 20 psi with a flowing hydrant. And for the planning level work, the city uses a residential fire flow of 1,500 gallons a minute for a duration of 3 hours. For commercial flow, it is typically 3,500 gallons a minute for 4 hours. And the commercial flows will typically require more than one hydrant. For the water supply criteria, the standard we've been using is to supply the maximum day demand with the largest well, plus the wells required for blending with the largest well out of service. Your circumstances are a little bit unique right now because at the moment, the wells 20 and 22 that we referred to earlier in the example also happen to be your wells that provide the greatest flow rate. And so if one goes out of necessity, the second one is not used in order to keep your water quality standards.
So when we were talking about firm capacity before, this is how it applies. This is kind of your weak link in your water supply. When this one well goes out, it takes the other one down. So that's kind of the focus of like a vulnerability that you've got. So in your case, your firm capacity definition is a little bit different just because of the fact that those two wells are tied together. That's your vulnerability.
The pumping performance criteria is to have a capability of pumping the larger of the peak hour demand or the maximum daily demand plus a fire flow of 3,500 gallons per minute. On any pressure zone or water service area that is of any size at all, which would be your central area, the peak hour demand is higher than a maximum daily demand with a fire flow. Now, the multiplier of 120% provides you a little bit of a cushion, which is used for several reasons. First of all, any city, particularly one that may be growing, it's not uncommon for them to have higher peak demands because they have more customers that have moved in from the previous year. And so it's difficult to precisely predict exactly what your peak hour demand is going to be. We also can't predict the weather and how weather conditions are going to fall on other factors that influence your peak hour demand. So that 120% is a factor that provides a level of conservatism to make sure that you're covered if you have any kind of or several kinds of undesirable events that would tax your pumping system. Now, the peaking factors that we have used in our calculations, a maximum day to an average day peaking factor, we've used 1.7. We have the same peaking factor for a peak hour divided the maximum day demand of also 1.7. If you multiply those together, you get a peaking factor of 2.9, which would be, if you took your average daily demand and multiplied that by 2.9, that is the flow rate that we would be assuming that your system should be able to deliver, what your peak demand condition would be. And the graphs below there just give you an illustration of how the water demands may vary in time. The one on the left is a seasonal demand variation, and neither of those are for your city because you don't have a SCADA system to measure this precisely, but you can see when you get to the summer demands, your demands are much higher than you would experience in the January, February timeframe when people are not irrigating. The hourly water demand graph shows how you have a peak demand in the morning, everyone gets up and showers and Sometimes people are doing their irrigating at that time of the day, and then the demand drops back down, and then in the middle of the night or later in the day it drops down more when the demand is not being used. So we need to be able to have infrastructure that can supply that variation in demands both on a daily basis and on a seasonal basis. Now, your water storage performance criteria is directly out of the state statutes, which is equal to the average daily demand during the maximum demand a month. So you would take your June or July demands and average out those demands for that month. And then the standard then is that you would provide storage that is equal to that amount. So you essentially have 1 day of storage that is available to you any day throughout the year. So that is a brief overview of the performance criteria that we have applied for the City of Goodyear. Do you have any questions on that?
One quick question. That's you talked about fire pressure. You talked about the pump pressure. Irrigation. Does that have anything to do with any of this, or is it similar? Or were you just talking about residential and commercial?
Well, the criteria would apply to all customers, including those who are irrigating. So.
Okay. Same pump pressure for irrigation. Okay.
Yeah.
And the peak, typically, the peak day is typically because of irrigation in the summertime. That's typically what we're dealing with, is trying to meet the demands associated with outdoor water use.
Thank you. Yeah.
Okay.
Any other questions? Turn over to Rob now.
So just before Rob gets started, so again, what Richard's part of the project was to look at basically what's necessary. We look at the performance criteria. We say, okay, how is your system performing according to these performance criteria for your existing population? So that was Richard's task. Now what Rob is doing is he's looking at your existing infrastructure to say, well, is it still in good enough condition to work and to be reliable to meet the demands of your customers? So there's sort of two components to this, if you'll recall the funnel diagram that I had. The first is, we look at what do you actually need according to the performance criteria. The second is, how is it performing and what do we need to do about it? And so that's what Rob looked at.
I'm not sure which speaker
You might
is
hear.
best.
Here, take this.
Is that actually a speaker? Robert Buss with Corollo Engineers. Work with the team here. I was chosen for this assignment primarily because I've been an engineer for 37 years. Been with Corollo 26 years here in our Phoenix office. I don't know. Maybe I was just available too, but that's a possibility. I think wisely, though, the city of Goodyear recognized that just having the performance criteria established and then doing the math to see does our supply match what our demand is was insufficient of an analysis, because it goes back to your point, what might fail. So they gave us an assignment, a very short fused assignment. We had 45 days to assemble a team and go to, both your buried asset, looking at your buried assets, pipelines and so on, and also the plant themselves. Condition assessment can be likened to any car that we've all owned. There are three components generally that we look at. The regular maintenance. Sometimes there's periodic repairs, so perhaps it's that VFD. Finally reaches a point where you just need a new car. So we all pay automobile repair expenses to extend our life, the auto life, and enhance the reliability. I've had actually 20 cars so far. My wife and I were going through this, trying to figure it out and thinking about it. We have a large family and gave them the cars. We've been through every one of these. It's a fascinating, personal story, and I think we can all relate to it. And so you bring that over to water assets, wastewater. And it's a little slightly different in that you're looking at some different components, but also the consequences are different because you have a staff and you run a city that people trust you. They're trusting you to provide basic services. For the buried assets, again, short time frame, we did not do any investigation of your buried assets other than desktop. The city has a very robust GIS system. All the assets are identified with a unique identifier. On the water side, pipelines, valves, fire hydrants. On the wastewater pipelines. So we approached our condition assessment from two angles, as it were. I had a team in our Phoenix office that, took the GIS system, looking for material and age, primarily, because for buried assets, not unlike plant assets, the material that you select is real important. And I think to your point, Mario, a VFD that's 17 years old is really old. Just is. The technology has gone beyond 1998 for VFDs, if you were to do that today and buy one. So age is an important component to consider, or element to consider when you're analyzing useful life. There's some good news, though, for you. On the water side, your water system has about 96% of the water pipelines are ductile iron pipe. Ductile iron pipe is a step above cast iron. Many people know the term cast iron. Ductile iron has more forgiveness in the sense of impact. That's the word ductile. You're able to have some flexibility with it. The material life of both, though, is about 80 to 100 years. 96% of your water lines are ductile iron. I feel pretty good living here, unless they were all 100 years old. However, in your case, there's still good news. About 65% of them are only 15 years old. I think Richard mentioned earlier about some of your assets will outlive us, and they will. I mean, hopefully they will. Maybe your children's children, we don't know. But just based on industry standards, your water system should outlast your children's children, just in sheer wear and tear and the second law of thermodynamics, as it were, everything wears out.
And I might add, just one benefit of having such high quality materials for buried assets is that these are in your streets. So you don't want to be ripping up the streets, replacing things constantly like you would a VFD or a pump that's above ground, because it disrupts commerce, causes problems with the roadways, etc. So part of the reason typically engineers specify a higher quality material for something that's buried is because you don't access it frequently.
Let's go to look at your wastewater. You may be wondering, how about that? Well, the main component or the main element to think about is corrosion in your wastewater system. Again, some good news. About 97% of your wastewater pipelines are non-corrosive. If you look at the pie chart there, about 76% are PVC and another 21% are vitrified clay. Both are not susceptible to hydrogen sulfide. A lot of the corrosive components that are in wastewater over time anyway. So in terms of the material selection, that's good news. In terms of age, it's still good news. Again, about 65% of your wastewater pipelines are only 15 years old. I didn't give a specific lifetime for vitrified clay or PVC. generally buried PVC, unless you've got some chemical that from an industry, it should last for 50, 80, 100 years. We don't know. It's a fairly new product industry-wise. I mean, it's been around since the 70s or 80s, but that's fairly new industry-wise. Vitrified clay, of course, is hundreds and hundreds of years. So, again, some good news up front. So on your buried assets, we really had nothing particular to add to the conversation in terms of CIP for the 5-year. We were looking, my job was to look at 5-year. What is it in a 5-year CIP that we've looked at, does Goodyear need to include in your CIP? And from the wastewater side, there was nothing. You are going to see things related to your manholes, and that's very, very common here in Arizona particularly. So you will see that in the 5-year CIP. Want to look at your plant assets. We took a team of civil, structural, instrumentation, electrical engineers out on several days. Again, kind of a compressed time frame. We worked with your staff to go to every site, every well site, booster pump station, particularly the Bullard RO campus, all 3 of your wastewater treatment facilities, all your lift stations. It's kind of a blitzkrieg, as it were, going to each. And I'm not going to represent this, though, that it was completely thorough, because how could it be? It was an appraisal level, but it was something that was done that you had not done before. And we gave a report to the staff that has, in the appendix, all of the forms that our staff was required to fill out. And the form itself was a field condition assessment form which guided every person's thought process when they were looking at the asset. It had questions related to corrosion, vibration, heat, in structural concrete, be looking at cracks or spalling, things that are pretty obvious to see as you're going through each facility. But the thing I really looked on, and I asked the team to make sure they kind of rated overall each facility, was on a scale of 1 to 5. 1 means it's essentially brand new. You had no 1s. 5 meant you really need to replace it today. There were a couple. The 4s and 5s all made it on our 5-year CIP list. There were a couple 3s that also made it on the list, but generally it was 4s and 5s. I'm going to look primarily, though, at those assets that overlapped with what Richard did in water supply. It would be short-sighted for us to say, well, we have all these wells that are shown here on the list, and they're going to last us for at least 5 years, maybe longer. But if you see wells 1, 2, and 3 are in red, and it's because the installation dates are very early in the century, early to mid-century, you can see. So we took the inspection date and subtracted out the installation date, and all of them were essentially 50 years or older. And the standard that is used here in Arizona for well life is somewhere between 40 and 50 years. So when you drill a new well, you may as well put it in your books for maybe 40 to 50 years for the well, not the pump, the casing. So 3 of your wells, we concluded, have no useful life. They're working. You're like me. I've had tires that I go to discount tire, and the guy says, I'm sorry, I can't serve you unless you change that tire. I mean, it's just gone. I said, well, I don't have the money. I got to use it. But again, you're in a position of trust. You're in a position of, now I know. What am I going to do about it? I'm responsible for what I know. And there are the 3 wells we concluded need replacement. And we found 3 more wells, part of it through videos that we have been taken by the staff over the past several years, that need rehabilitation. So if you see the total pumpage, we think we have 8,910, but we know about 3,000 of the pumpage may not be available to us in the next 5 years. Something may happen to the first 3 wells. The next 3, we don't know. So about a third of the wells then need replacement or rehabilitation. And that's reflected in the CIP that you'll see at another time.
Any questions?
You say,
No, okay.
When you say replacement, do you mean replace the parts or drill a new well?
On replacement, I mean replacement, a new well, drilling a new well. And we've talked to staff about it. We've had some discussions on how best to do that, and it's all reflected and bundled up in the CIP that you'll see later.
So that probably goes back to was it page 23, where you said 65% of the water pipelines are 15 years old. I was going to ask a question, what about the 35%? But I think that kind of is covered in the later slides.
65% are 15 years old.
It leaves 35.
35% are older.
And older is?
Well, we have the database, and I guess we could go back to the chart if you're
That's
really
why I was going
interested.
to try to tie it to that one chart you had earlier.
There you go.
Collection system or water?
I think either one would be fine for me. But if you look at 1950-ish, I guess, was the first, reliable as-builts. That's in the GIS system. And then, some of you probably may have lived in this area to see the early 80s and the 90s and then clearly the 2000s. So 35% is represented essentially sooner than the year 2000. I had to cut a line somewhere. So I said the last 15 years, 65% of your water lines are fairly young. You've got a lot of life left. But 35% are older, so I'm not sure if I'm helping there, but hope that makes sense.
Does that answer your question, Chairman?
Sort of.
Well,
I wanted to know a little bit more, just kind of switch on you real quick, about the appraisal level. You had this field condition assessment. I just was wondering if you can talk a little bit more about that.
The 1 to 5, you mean?
Yeah, that assessment that you've done that
Yes.
allowed you to create your slides on page 25, right? You said there was an appraisal level or field condition assessments. You said they're rated from 1 to 5.
Yes.
And then I really didn't see a slide that had that rating from 1 to 5. Maybe I missed it.
Well, no, you didn't miss it. We didn't have it. And actually, my part, we figured would be somewhat to the end only because the bigger part is probably the performance criteria. I have all the forms that we took. The actual criteria is 1 is essentially new. 2 is you might have to commit like $50,000. It's a judgment call of what you need to bring it back up to a 1. 3, you can see where this is going. It gets bigger and bigger. At 50%, at a 5, if you look toward the end there, yeah, you can have that.
Well, as an engineer, I'm wondering, when you talked about this field condition assessment, I'm thinking, okay, was there some type of engineering? It sounds like it was just a new, medium, older. There had to have been some more meat behind this assessment.
Well, there's I don't know what you mean by more meat. We could have done a lot more analysis. This was a short fuse. It's an appraisal level. We used engineers that have done this for years, and we talked to your staff in terms of some of the components. We did this project in Albuquerque in which I told them, well, your pump should last about 15 years. And they said, why are they wearing out in 8? And I said, well, what's your maintenance? Because if you go back to the car slide, there's routine maintenance and there's periodic maintenance. And that particular segment of their group just wasn't doing the kind of maintenance that they needed to. I'm not saying that you have this group. You have a good group. But we didn't have the time to get into the details of every component. And there are a lot of components on each of your facilities. So we went through and used engineering judgment, no question, but primarily age more so than their maintenance records. But we also talked to them. We had one workshop, particularly at the beginning, where we went through all their facilities and said, tell me your problems. Tell me where things that keep you up at night. What you can't go home at night and sleep because of, and whatever that is. And so that was factored into some of your of the wells, some of the pump stations, and some of your lift stations.
Can you go back to, you mentioned
Sure.
maintenance records, so that wasn't part of your field condition assessment?
What was not?
You said maintenance records.
That was not, no.
No. So you didn't look at preventative or corrective actions or
No.
anything? You just said, okay, this guy is 50 years old, therefore it needs to be replaced.
And also asking the staff, how frequently are you replacing components? You know, just getting a general sense from them as to the condition of the equipment. So it was somewhat anecdotal, but based on experience.
And just to give a context to how you could do a more thorough but more costly and time-consuming, not that what we did didn't have the value that we think it has. Again, Albuquerque, I think it was 6 months to do just their wastewater system. Their system is bigger, obviously, but I hope that's helpful. I mean, right now, what you have is a sense that you have an adequate water supply. And what we've found is you might not for the next 5 years. It might work, but based on the data, based on the conversations with your staff, you need to take some action in the next 5 years. That's what we say.
Committee Member Sharp?
Going back to slide 60 and tying it into the perfect storm slides, slides 24 and
Was that slide?
26.
Yes, you're welcome to take that. Was that slide 60, Committee Member Sharp?
Pardon me?
What slide number again? I'm sorry.
Okay, I'm looking at what they say needs to be repaired
Okay.
and going back to the perfect storm slides. 24, slide 24, slide 26, and slide 60. 60? Yeah.
What was that last slide?
Slide
Excuse me.
24.
60? Yeah.
Yeah, it's slide
24,
24.
26, 25, 26, and 60. So,
If I'm a little confused on the 60, I don't see a 60.
It's the slide right, the number down here. It's not the page number.
page
There
25.
you go. There it is.
Oh, I got it.
Down at the bottom.
On 24, 25, and 26.
Yes.
Oh, okay. I need newer glasses. Okay. So, with these needs replacement slides and everything, can you say that you've tied those wells in that illustrate the perfect storm into your need replacement and need rehabilitation? So are we taking care of the perfect storm situation by your information on what needs to be replaced and needs to be rehabilitated?
Yes, in the improvement projects that we recommended, we have listed not only additional wells for capacity, which is part of the work that we did, and then Rob's evaluation also looked at what wells needed to be rehabilitated or replaced, and so we took the two together, and that will comprise your well recommendation list.
Okay, but you made the comment that there were two wells that were tied together, and that was part
20
of
and
the
22.
problem.
Yeah, 20 and 22.
20 and 22.
The condition of wells 22 and 20 are okay to continue to operate.
But that was a perfect storm
Right,
situation.
but that's because if one goes out,
Right.
then you have a problem.
Okay.
So what we have to do there is, that's a different discussion. That's where you have to find an additional 3.2 MGD of water supply to prevent that perfect storm from happening. So that's a need for new wells in addition to the replacement of the existing wells.
Okay.
Does that make sense?
Yes.
Okay.
Other questions?
Yeah, I want to go back to this, just so I get this clear. 20 and 22, if 20, I think it's 20 goes down, 22 goes with, or vice versa. Part of the perfect storm is, that's how it happened. We've got 3 other wells that need replacement, sounds like fairly quickly. And I think that's where she was going down was, okay, what happens if these guys who are old do go down tomorrow along with 20 and 22? That is the perfect storm I think you're talking about. Is that because I didn't hear her question answered. You follow me on that?
Yeah?
Okay, you got
Right.
3 pumps that are bad, 20 and 22 that are linked together. If those 5 go out, where are we?
In trouble.
Yeah.
That's what she was trying to say.
You are
That is
almost
what I think.
I mean, another,
Okay, that's what she was trying to say.
another way of looking at this, if you look at the slide 25, look at the demand at the time of the event, which is 11.7 MGD, your total production, which is 12.9, which in reality is not very much above the 11.7. And so part of the point that we're making is that when it comes to water production, you have a problem because you don't have sufficient production to cover you when equipment goes out. And you'll see when at the recommendations, the wells are a big component of the projects and costs to try and rectify this situation for you.
How would a library of parts alleviate that situation?
A library of parts would help you for those specific events or parts that could come out. In this case, this one VFD part, that could help you to put that back into service. But I think it's important to realize that even if you had complete parts redundancy of those things you could replace, you're still short on water production capability. And you still have wells that, because of their age, they're likely to have limited usefulness going forward.
The actual well itself, I don't want to insult your intelligence. I don't know what you know about a well. But the well casing is like a big giant metal straw that goes all the way down into the ground about 1,000 feet. They don't last forever. That's what's old. The pump sits on the top, okay? Or the motor sits on the top. But it's the casing itself that if you're in danger of the whole thing collapsing and then you can get no water out of it. It's like a big giant straw that goes into the aquifer. That's what's bad on those 3 wells.
So how long does it take to replace that sleeve?
To drill a new well and equip it, it's probably like a 6-month process.
So we have 3 wells that need assistance, and it's going to take 6, if we started today, it would be 6 months out, and 20 and 22 could fail somewhere in time because they're linked together. So
Yep.
that's why the red color print.
Right.
Well, and I think, Chairman, you also have to remember, too, you're looking at permitting, financing, studies. It could be pushed well into a year. I happen to be going through that right now, so. And also regulatory. Can you replace the well? Or do you have to file for a new well, which would be a new source? So
The likelihood is that we would be able to re-drill within the 660 feet. Yeah. But the other issue right now is that there's a lot of competition for wells because California's in a drought. So most of the drillers are in California right now. And so that adds to the complexity of this, is trying to get drillers back here to get a new well drilled.
Before you say, I want to ask a stupid question. So when this thing caves in, you say we have to re-drill a new well. We can't take that existing one there?
We can't put a new liner in it?
We can't put, yeah, that's,
You
can't put a new liner?
I mean, to pull that you're talking about like shards of metal. Usually you basically backfill the well, plug it up, and you start over because it's so difficult to pull all of that out once it's collapsed. And to re-drill it before that happens, the way that drilling equipment works, that there's a mud component to it, and it just may not give you the same capacity that you had in the beginning. It's better to just kind of go next to it a certain distance and re-drill.
Have they made technology, for example, if you're home and your line cracks underneath your house, because they ran, at one time they ran a lot of the water lines underneath, so it cracks. It's a 3/4 inch, and they turn around and they stick a 1/2 inch inside that tubing. Is there a technology out there to do something like that?
Yeah, there are well rehabilitation methods that are employed. Again, there comes a point where there is no more rehabilitation that you can do, and you simply have to replace it.
So we've potentially could have two processes. One, to do that while pulling permits to go dig for new wells to create some 3 new wells.
Well, there are 3 wells on slide. I don't know why it's numbered. I guess it's numbered 650. Page 25, slide 50. There are 3 wells that do need to have that rehabilitation done to them, in addition to the 3 that need to be fully replaced. So what you were talking about, there are 3 wells designated for rehabilitation right now.
There are, okay.
Mm-hmm.
But what, then maybe now here, I see Mark standing up, maybe then comes the next question. Are we going forward with permits and those sort of things to look at drilling new wells?
Mr. Chairman, members of the committee, just want to add one more thing. We're going to have to do a comprehensive a wellhead study looking at geographical areas where we would actually not impede on other well owners. It's a well spacing, well impact analysis. We also have 2 Superfund sites in the city and a wharf site, which really limits the geographic area and the aquifer area that we can actually put wells. So we've been internally looking at where we can actually look for new well sites, and it's very, very limited. Just wanted to bring that up, that alone is a study that's probably going to take between 6 months and a year to find out where we can drill, and then we have to go to the Department of Water Resources and get exemptions to go beyond the 660 rule, which was brought up a few minutes ago, to move away from either Superfund or other areas. And then it's the permitting and doing, and then if you get the waiver for the 660, now you're into a well spacing, well impact analysis, which is a groundwater model. So just realistically, we're looking at probably 2 years to drill 1 well. And that'd be the first well that would actually be drilled 2 years from the time of when you start a wellhead analysis in the city of Goodyear, just from all the dynamics here in this. I just want to make that clear that this is a very long process.
Yeah, I should have.
When did you start, sorry for that. When did you start this process? Because, I mean, we see a study here. It's talking about 3 wells that are old. It sounds like either try to bore them out. I don't know what the correct terminology is, or make a new well. Maybe you knew ahead of time, or did you just find this out that we need to go forward and drill a couple more wells? Because it sounds like we're in a, I don't know, I haven't heard any other committee members say it yet, but it sounds like we're going to have an issue here pretty quick.
So the question is, when did they know?
When did they know? When did they know? When did they start this process?
Well, and sort of as a follow-up to that, I mean, are these results unexpected? I mean, are these unexpected findings? I imagine not. I mean, if you have aging infrastructure, wells that are up to 50 years old, I mean, I would think these are anticipated.
Yes, absolutely. Here you go.
Okay, Mr. Chairman and committee members, these wells have been in production for the city of Goodyear for a number of years, and we have had an aggressive maintenance program on these wells, where we're into the wells every 5 to 7 years. We actually have a rotating cycle where we go down, we pull the pumps, we go down, we clean them, we video log them. These have just gotten to the life expectancy to where we just can't really do a whole lot more with them. So we have all that information, as Robert mentioned. We've got video logs, we've got internal video assessments. We know the depths to perforation. We know where the water comes from. The thing is that we've just been into them for so long. There's just not a lot of metal left on these casings.
Well,
they're aged.
Let me interrupt here. For example, when I'm purchasing capital equipment, I know when to start at that process. Mm-hmm. I'm well aware when to start it. I don't start it when someone comes at me and says it's 50 years old, or as I'm saying, 2 years out, I'm already looking for new capital equipment. I just want to know what activated you, or did anybody get activated to see that starting point? That's kind of what Jake was mentioning over here. Mm-hmm. What did anything start that momentum going forward? It sounds like it didn't. It's not like today we find out, at least we're finding out, that now we have 3 wells that are old, and then 22 and 20 are tied together. If they go, we've got the perfect storm. Is that it? Mm-hmm.
We've had that information. That's part of the study that we're doing right now, is to evaluate this to determine what the 5-year CIP to start replacing these things are. So we've got that historical information, and we're working towards now developing replacement plans as well as rehabilitation plans and the such. And that's part of the purpose of this study, is to help us to indicate that.
Mark, either for you or Larry Lang, do we have a capital budget for this?
I'll let Larry answer that.
That is all part of the process. As this conversation goes to next week, we'll show you what the costs are, more specific on the improvements, how that ties in with that budget, how that impacts then what those costs are, how that can impact the rates. That's all part of the process of going through here. Do we have a capital improvement plan in place today? We do. Does it include all of this? As a result of this information, it needs to be modified. Some of the items are included in our existing capital improvement plan. Some of the items need to be adjusted. And we'll be going over that next month's meeting in much more detail, but a very good question.
You had a placeholder on your presentation. It said something along the lines of $4 million or so for long-term capital expenditures. I think that was last month. Is that what you're referencing?
That one, yes, that would be part of it, but this is a more specific part of it. We'll bring all of those schedules to you because I don't want to repeat part of a slide that I don't remember exactly.
May I address something that Mr. Manerick brought up earlier about cost benefit? So hopefully our discussion on the performance criteria helps everybody understand sort of the baseline condition that we're trying to achieve on your behalf. And it's statutory and it's based on engineering best practices. The cost benefit analysis happens on a specific project. We're developing cost estimates associated with sort of an average of what it takes, say, to put in a new well. When you get down to the project level, you say, what motor do I want? What components do I specify? And that's when you start to look at the cost-benefit analysis of various components associated with a project. So we're not making an assessment of cost-benefit. You need this baseline condition to provide service to your customers. And then at the project level is when you typically do more of an in-depth analysis of what's the life cycle cost associated with this equipment, what is that going to give us, that kind of a thing. That's when that's done, is at the project level.
Thank you. That's very clear.
Other questions regarding the presentation? All right. Well, we'll move on to the committee. Thank you very much. Thank you.
Thank you very much.
We'll move to the committee discussion. And at this time, we wanted to have some time for you to discuss either the Integrated Water Master Plan or if you had questions related to the information that you were provided via email from Anna, or other topics that we might need discussing related to your objectives or the study. So I'm going to open the floor.
Oh, yeah, I read it.
Any thoughts? You'd like to share? Questions, comments?
Mr. Chairman?
What committee, madam? Committee member Manick?
I think that if we spoke to 6.4, it might facilitate the agenda, a conversation here.
Is that, do we want to move to that discussion? It's about subcommittees?
That's what I was just moving to to amend the agenda. I'm making a motion. Amend the agenda.
To add it? I apologize.
To have discussion 6.4 and before 6.3.
Oh, to have 6.4 before 6.3. Oh, got it.
So that's my motion, Mr. Chairman.
Need a motion?
I'm moving to amend the agenda.
I thought I thought we could amend the agenda. That's 6.4, and we're actually talking about discussing the
committee discussion. Is that where we are?
We're not there quite yet.
We're at committee discussion.
Did I miss that?
We're at committee discussion, not subcommittees yet.
Right, so we can't have a motion because we're at committee discussion, right?
Well, I mean, that's up to the chairman.
Well, that's what I'm saying. I don't think we can do that. Once there is no discussion, then we move.
Okay.
Okay? So first...
My discussion point then, Mr.
Okay.
Chairman, is that if we get through this one quickly and we get to the discussion of possibly subcommittees, then that might facilitate a discussion that might be difficult to have without that discussion.
Are we referencing time here, or?
No, actually,
Okay.
I was referencing depth of discussion.
Mr. Chairman, I think what he's trying to say is, if we need, you need to do subcommittees before you do committees. Is that what you're trying to do?
Well, sort of. What I'm saying is that if we have a general discussion, I'm proposing that if we have a general discussion, that's fine. We've had a couple of those. We bring up points.
Okay.
But sometimes, in my opinion, they can be meandering because we're not focused yet. Going back to what we did almost a year ago, and I think that if we had a discussion about subcommittees, all that helps us do collectively is to focus almost in an outline sense of the various important parameters that are before us, instead of the different agendas we might have, and I don't say agendas in a bad way, but the different ways we see things. It might give a guiding principle in a separated format.
I don't disagree that subcommittees is a discussion we need to have. I believe we need to have that discussion. I just want to get through these discussions prior to that. If we're done with this, then we can go forward and have a motion.
So this discussion is
Right,
about all of this.
There's two different things. That's correct.
I withdraw everything I just said and apologize for wasting 3 minutes. I did not understand this one to this.
That was 3 minutes and 30 seconds.
No, I watched the clock, so it was 3 minutes.
Okay. So is there any other discussions in general?
About this.
So it doesn't seem so. Are there? I don't want to discount anyone. Is there any questions, comments?
I just want to talk about subcommittees.
All right, then let's move to the subcommittees. And we have that. So I guess there's a few questions that we could ask when it comes to subcommittees. There were some on the slide that I was going to put up, but it is now. Oh, magic. Thank you. So, one of the questions just for you to consider while we're talking about subcommittees is what would be some of the topics, what would be the purpose of subcommittees, to talk about the timing, and then if there another option as we're looking at that could be, and to still add the same value, is to have more meetings. So those are some different things to discuss. So I will let you have a discussion. Any thoughts?
Jump into this real quick. Figuring, Peter, one of the things that we did talk about was having 2 meetings per month instead of a subcommittee. So I'd like to throw that out there as a thought as well. Go ahead. Committee, sure.
My feeling, originally I was for subcommittees because they could deal specifically with a specific element and draw more questions from that area. The opposite of having them is that it is going to be time consuming. Because when you have a subcommittee, you need to bring it back to the full committee for discussion. So it wastes time.
That is correct.
And so I see the value of a subcommittee, but I'm wondering if we can't combine it in an additional meeting per month. It seems that, for instance, if we were to have an additional meeting in the month, we could set the agenda to address different topics that we wanted to put forth in a subcommittee and have the whole committee participate. And that way we wouldn't be leaving anybody out, and I think it would go faster. So that's my response. I would not be for subcommittees at this point. I would be for additional WPC meetings.
And Mr. Chair, I would echo Marge's, all of her points. I'm not in favor of subcommittees. I agree that they would probably become just about quite frankly, repetitive. All the information discussed in the subcommittee will probably be brought up in this committee as well, and I think it's a waste of staff's time, quite frankly. I think if issues get to the point where we're getting bogged down and we're not moving, then I think we discuss the possibility, whether it's a subcommittee or an additional meeting within the month. But just to start from this point and say, let's create additional meetings, I just don't think it's the best use of time. I think staff has done a wonderful job. These follow-up items, I don't know who prepared this, but it's about as thorough as it gets. And it even seems as though questions were raised after the committee, so folks were perhaps making calls to staff, and those questions were all addressed. So I haven't gotten the sense that, A, we've been bogged down in any issue, that we needed more time to address any of those issues. And quite frankly, I think staff has gone out of their way with these presentations and all these notes to make any additional meetings unnecessary.
I would agree. Staff's done a great job with their notes. This is some of the changes that were made when we first brought up the term subcommittees or adding additional dates to our meetings. So,
other thoughts?
I think that the amount of SME subject matter experts that we have on this committee is limited. So if we divide them out, we're limiting our resources to be able to come together. I don't believe that subcommittees is an answer at this point. I think that we need all of our minds to be able to put all of this together.
Other thoughts? Committee Member Menard, may I ask?
Yeah, well, my opinion is it's the depth of knowledge. First, my premise is that I don't think we need subcommittees if the committee as a whole doesn't think it needs a subcommittee. So, hearing from my colleagues, I don't intend to press the issue. I just wanted to bring it up. But I think subcommittees do not waste time. I think they're efficient, generally speaking, because it allows people to zero in efficiently on information in depth and then report to the full committee. And if it has the full committee's trust, then it's an efficient use of time. If it doesn't have the full committee's trust or it doesn't have the expertise, well, then it is a waste of time. And that's what,
well, at this moment in time, as Jake mentioned earlier, committee member Himman mentioned earlier, he felt that at this time it's not needed. What do you feel about that?
I feel right now, personally, that it's overwhelming for me to become well enough informed about infrastructure, sustainability, rates, to really understand all three well. But I think I could understand one of those three pretty well, and with my colleagues, and confidently report back to the full committee. That's what I think. I hear that the others think, no, I think I can be competent in infrastructure and sustainability and rates, structures, and we can have the discussion. And perhaps that's true. But that's why I think subcommittees allow focus, a flashlight, and that's their purpose. And if the committee as a whole does not feel that it's overwhelming, then they know their own resources and they know their own ability to absorb the information that's required to make good decisions.
And Committee Member Menard and Chairman, if I may, also that'll help us. We heard infrastructure, sustainability, and rate structure. So I'm glad that we have Carollo engineers listening in the audience. And we also, I believe, have economist.com. I thought I saw him here as well, the gentleman who's going to be presenting the rate study in May. So given that you heard that those are some things of interest, maybe we could kind of incorporate some of that in the April and May meetings in your presentations, just to see if maybe we can dive into that a little deeper. Oh, sorry, it was infrastructure, sustainability, and rate structure.
Those were, when I made my comments at the last meeting, and I said I was going to come up with a motion, which I'm not going to do now. Those would have been my three recommended subcommittees with loose conversation after hearing what I've heard over the last 9 months. Infrastructure, sustainability, and rate structures.
And actually that fits perfectly into when we talk about the CIP projects or the proposed Infrastructure will be a big component of that, hopefully sustainability and the rate structure in May, so that seems to fit nicely. Other thoughts on subcommittees, if there are any?
Seems to me it's dead, Mr. Chairman.
Okay.
Seriously, no, I say that respectfully. It seems that the committee as a whole doesn't want to have a subcommittee.
I think it's, the committee has mentioned that at this time, that they don't see a need for subcommittees or going to an additional meeting
Wait, I
per
didn't hear
month.
that.
That's what I thought I heard from.
No additional meetings? I thought I heard different from March.
I said it would be
Necessary.
4 additional meetings when we determine that, it's necessary.
I see.
Correct. See.
Move it forward.
Okay.
Given that, I will, apologize.
Sorry, I would actually recommend that the 3 titles that Larry's talking about, we have an additional meeting, 2 weeks apart to just strictly discuss those particular subjects.
Maybe later in time.
Mm-hmm.
That perhaps after we, just as a suggestion, perhaps after we listen to the CIP projects, and that'll give you more about infrastructure and about some of the proposed things. Maybe after that, or after that meeting, you can consider. Would that be something you'd be willing to entertain? Okay. I'll turn the meeting back over to the chairman.
Okay, thank you. Now it's time for questions from the public. Are there any comments, question cards? Well, then now it's time for the information items. Does anyone on the committee have information items they'd like to share? And what they are, something along the lines of report on current events, maybe presentation by boards, anything other than we've talked about tonight? Okay, well, the next meeting will be held April 14th, 2015 at 6:30 p.m. There will be no further business to discuss. This meeting is adjourned.